my dudes? We're back at it again with another video. Are y'all ready? Cause I'm ready. This build's getting closer and closer to being finished. But today, we're going to mic out the engine like 90% of the way. The rods and pistons are still at the machine shop, so as soon as we get them back, we can measure the bearing clearances and throw them in. But today, we're going to be measuring piston ring gap and main bearing clearance with some T gauges and some micrometers. A couple of tools that I have to do this miking, blueprinting. I have a set of telescoping gauges, which I'll be able to measure the bore. Basically these, they expand, they look like a T, but they expand. You tighten the lock nut down on the end of the gauge and it'll keep still so that you can use your micrometers and measure the distance. That basically gives you your bore. I have the honing tool. Also, I have the piston ring grinding tool. This is a diamond wheel and a piston ring compressor to install the pistons when we have the rings on them and it's ready to be installed. So first things first, let's take a look at these piston rings. Now I don't have a preference. I've used the NPR on the D16 that's currently in my car, and I've used the Hastings on my last B17, so I don't have a huge preference. They both sealed really well, and it wasn't like I didn't have an issue with them at all. Seeing as how these are going to see boost eventually down the road, I'm not really sure which is better. As long as I gap them correctly, we should be alright. But so comparing top ring to top ring, the probably can't see this, but the top ring on the inside edge of the NPRs has a bevel. Now this allows compression to get inside and force the ring out to add more compression to allow better sealing. The Hastings ring, I don't see anything like that at all. This is just a rectangular square ring with a round face. So I'm gonna go just off that. I think I'm gonna go with the NPR rings. But let's look at the second ring. So the second ring has this stepped edge on the outer side. This allows for better oil scraping on the downstroke to aid in less oil consumption. On the Hastings rings, there is a beveled edge on the inside. Now, from my knowledge, this beveled edge allows for more volume, and with more volume becomes less pressure. So essentially, as the gases escape past the first ring, and in between the first and second ring can build up pressure. Now this slight bevel is supposed to add more volume, which decreases pressure, which will allow for better sealing, and at higher RPM, it can cause ring flutter.
What I meant to say was the buildup of pressure between the two rings at high RPM can cause ring flutter.
On the outside of these, there's no step. It's just square. I believe it might be cut at an angle, but for that reason, I am going to just go with the NPR rings. So let's get these gapped. So generally, what I like to do when I start to gap the rings is I like to take 3 measurements of each ring. Top of the cylinder, about halfway down to the stroke, and then bottom dead center, basically, just so I can get an overall idea of what the gap will be up and down and through the cylinder. So I'll take 3 measurements, see what the gap is currently, and then gap the rings to the spec I'm going with. The factory max tolerance for the ring gap, as it was sitting off of the showroom floor, is 15 thousandths. Because this engine will see boost, but not much, I may only see anywhere from 4 to 13 pounds of boost eventually, but I still want it to run well naturally aspirated while it is naturally aspirated. Like I said, the max tolerance is about 15 thousandths of an inch for ring gap. I am going to be opening the ring gap up to 16 to 18 thousandths on the top ring and 20 to 22 thousandths on the second ring. This will allow for more expansion when the heat gets to the ring, and it'll keep the piston rings from butting up against each other and causing the ring lands to break or locking the engine up. We'll open up the gap a little bit. It'll allow for good all motor performance, and once it is boosted, it'll allow it to take more heat and not cause any engine failure. When you're doing this, make sure that you keep these separate. If you measure one for cylinder 4, you keep that with cylinder 4. If you mix these up, your ring gap is not going to be consistent throughout that cylinder. So I like to record everything, obviously for my own knowledge, but also to keep track. And when you're gapping these rings, your tightest tolerance should be your spec. So say the middle of the cylinder is a little bit wider than the top, and the top and the bottom are around about the same, say. If the top is at your spec, that's perfect. If you measure the middle and you set the middle at your spec, then the top could be tighter than your spec, which can cause engine failure, and you definitely don't want that. So your smallest diameter of the bore should be set to your spec for ring clearance. So first we're going to work on cylinder 4. Now I have an old piston here that I'm going to be using to center the piston ring in the cylinder. This is from an old B17 that I had. I think it might have been running a little lean, or the piston ring gap could have been too tight, caused the ring land to break. But I'm going to use this as a tool to center my piston ring in the bore. One thing I forgot to mention is to lube the cylinder before you try to do this. It'll be better so you don't scratch the cylinder or scratch the ring or cause any binding or anything. So make sure you put lube on the cylinder, and from then they should slide pretty easily. Lube it all up. We should be good to slide our piston ring down into the cylinder. Check our first clearance. Now we have the ring in the bore. Take our piston. Push it down until it's about flat. That should be good. We'll start with 15 thousandths. 15 thousandths fits, no problem. Move up to 16 thousandths. 16 thousandths fits, no problem. Go up to 17 thousandths. Fits, no problem. Go to our spec of 18. Fits for a little bit of snug. Let's check 19. I cannot get 19 to fit. It doesn't fit all the way, and you need to make sure that it fits in all the way and seats up against the cylinder, which this does not, and it's too sticky, and I'm not forcing it. So 18 thousandths, that is our clearance, and that fits very well for the top. Now let's seat this piston ring further down the cylinder and check the center of the bore. We'll go until the piston skirt right above the wrist pin seats flush with the top of the cylinder, like that. Pull the piston out. We'll start again from 15 thousandths. Check out gap. 15 thousandths fits. 16 thousandths. 16 thousandths fits. 17 thousandths. 17 thousandths fits. 18. 18 fits. Let's go for 19. 19 fits there. It was kind of snug. I don't think 20 thousandths is gonna fit, and it doesn't. So our spec for the center of the cylinder is 19 thousandths. Now let's check a little further down. We don't really have to go too much further down, so I'm just gonna go until the skirt meets the top of the cylinder. Start at 15 again. Fits. 16 fits. 17 fits. Our spec of 18 fits. 19 looks like 19 does not fit, so our spec is 18. Spec of 18 fits at the bottom. So going from top to bottom, top gap is 18 thousandths, which is our spec. Middle is 19 thousandths, and the bottom is 18 thousandths. So our top ring is perfect. Fits our spec, meets what we need to do. Now let's move on to our second ring. For our second ring, we're going for a gap of 22 thousandths. Take our piston, center it in the bore. Alright, let's check our piston ring gap for second ring. Start off at 19 thousandths. That fits 20. 20 fits. Check our 22. This gap looks pretty big, so try 24. Try 26. We're going to put two of them together because this is getting a little out of hand. 12 and 15, that's 27 thousandths. See if that fits. Alright. We're going to do a 10 thou and an 18 thou, which would be 28. That fits. If this continues to get too big, I might have to check the Hastings rings and see if their gap is a little bit tighter, because we're moving up to close to 30 thousandths, and I'm not a huge fan of that for my second ring gap. Alright, 10 and a 20, 30 thousandths. Still too much gap. I'm going to check the Hastings ring gap. Alright, let's try the Hastings rings, second ring. See if it's any better on gap than the NPR. Already looks like it might be. Alright, let's check this gap. Our spec is 24. I'm gonna go straight for the 24 and see if that fits. It does not. Let's see what the spec is. 22. No. Let's check 20 thou. 20 thousandths fits. Let's try 22. 22 thou does not fit. So we're gonna have to grind this one a little bit so that our spec is met. So we have to open up this ring gap to allow for our gap to be met. Using this tool, you want to be very careful that you grind both sides very, very evenly and you don't take too much material off. So you need to hold the ring on both sides very, 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 very gently. Squeeze it into the diamond and you slowly grind away. I just did 3 rotations. I'm going to measure again, see how much was taken off, see if we're good in our gap. And we'll go after our 20 thousandths. That didn't fit. I know our 18 fits. Let's try the 19th thou. Nineteenth thou almost fits, so we need to take more material off. Check our ring gap again. Center it with our piston. 20 thou. Fits perfect. Let's go for 22. Fits perfect. For our 24. That doesn't go in. So our gap of 22 thousandths is met at the top. Now let's check our gap halfway down the cylinder. See if our gap is still correct. 20 thou. Perfect. 22. Slight drag, which is good. Not forcing it. Now let's try 24. Just make sure it's not any bigger. 24 thou does not fit. So our spec of 22 thousandths is met on the second ring. Now that's basically the same procedure for all 4 cylinders for both top compression rings. I'm gonna knock those out and I'm gonna catch back up with you guys. And finally, we have the rings gapped. Now it's time for the bearing clearance check. So essentially, to do the bearing clearance check, we're going to install all of the main bearings. We're going to torque down the main bearing bolts, the main studs, and measure with T-gauges the bearing width. We'll take 3 measurements, up and down, side to side, and then at an angle. But we'll take 3 measurements of each, and then we'll measure the diameter of the main bearing on the crankshaft. Gotcha! But the main bearing on the crankshaft, the main journal, and we'll subtract that from what we get here with the bearings installed, and then that'll give us our clearance. Now with all the main bearings in place, you want to torque them down. Once you torque them down, then you can use your T gauges to measure the width. And that'll give you first measurement. Then you compare that to the diameter of the crank main journal. And that gives you your clearance, the difference between the two. So we'll torque these down first to 25, then 56. And we'll check our clearance. Now the reason you want to do this is because torquing them down will give you the exact diameter they will be when the crankshaft is in and the mains are torqued, so give you the most accurate measurement. So now with all the main bearings torqued to spec, what you want to do is get your T gauge. Now this, I have it locked right now, but if I unlock it, they expand out. They're spring loaded. What you want to do is slide the T gauge inside, and then at the bottom there's a little lock that you can lock it with. So basically just slide it in, try to get it as dead center as you can, lock it in place, make sure there's no extra movement anywhere, and there isn't. Once you have it locked, then you can take your micrometer and measure it. Now how this works, it has a piece on the end here, and whenever it stops, like if it were to squeeze onto this and it wants to stop, this clicks like a gear, like a bicycle gear basically, when you pedal in reverse. It doesn't allow you to tighten it too much more, so that lets you know that you're done. It gives you the most accurate measurement. This is very difficult to do, but with that measurement, I got 55 millimeters on the dot, which equates to 2.17 inches. Now that gives us our first measurement. Basically the same thing through all 5 main journals. Once you have them, then you just measure your main journal on the crankshaft, minus that from the measurement you got there, and that gives you your clearance. Basically that's it for the main journals. Just do that through for all 5, measure them, then you measure the diameter of the main journal on the crankshaft, minus that from the measurement you get here. That gives you your clearance. But I'm gonna get through with that and then we'll catch up right after. So from my measurements, all of the main bearings with bearings installed, the clearance is well, the diameter is about 55 millimeters. this 0.02 and 0.01 millimeters really doesn't make a huge difference. 0.01 of an inch, a hundredth of an inch, it's not really huge. But once we get the once we mic out the crank, then we'll know our clearance and see what we're working with. So now that we have our main bearing diameter, we're going to find our main journal diameter and then subtract that from our main bearing diameter, and we basically get our clearance. So our first main bearing size was 55 millimeters or 2.17 inches. So let's take this measurement and see what we come out with. Now to do this, like I said earlier, this little gear sprocket type thing mechanism will stop you from going any further. I'm holding it still, it won't allow it to go any further, so it gets the most exact precise measurement. So let's see what we come up with here. Alright, so it looks like our main journal size is 54.96 millimeters. So that gives us a 0.04 millimeters clearance. 55 minus 54.96 is 0.04 millimeters. 0.04 millimeters equals 0.0016, I believe. I will double check, but if that's so, that's right on the limit of the service limit. That was correct. 0.04 millimeters is 0.0016 inches. And that's decent. I do have an ACL orbital high flow oil pump that's going to be going on this engine, so I don't feel like that clearance is going to be an issue. And also, I drive this car hard. I beat it, you know, racing, stuff like that. So this little bit wider clearance isn't a huge issue. It's not. It's on the standard service limit of stock, so I'm okay with that. It's going to allow for a little bit more expansion. It's not going to hurt anything, and under boost, it'll allow for a little more heat to get into it without it like cramping up or getting too tight. So that's decent. Let's take this second journal measurement and see what we have. Comes out to the same exact thing, 54.96, which gives us 0.04 millimeters of clearance. So that's good. I do want to check the center and 4 and 5, see if we have any difference in bearing clearance. So the measurement on the third main journal comes out to be 54.97, and since our measurement for the main bearing for number 3 was 55.01, that still gives us our .0016 clearance. Let's check number 4 and number 5. So with our journals and bearing clearances all mic'd out, this is what we've come up with. So our clearance is .0016 on 1, 2, and 3 main, and .0012 inches on 4 and 5. I'm not sure why it's a little tighter there, but it's still within spec. It's still worthy. It'll do just fine, I believe. Now let's move on to measuring the diameter of the bore. And as soon as we get the pistons back from the machine shop, we can check the rod bearing clearance and then put the rings on and throw the pistons in the block. Now usually when I'm measuring the cylinder bore, I like to take 3 measurements, top, middle, and bottom, and also 3 measurements at each specific point. Straight across the piston pin, across the thrust surfaces, and then diagonal to that to check for any egg shaping of the cylinder or out of round. This is a very thorough way of doing it. This is the way I do it. You don't necessarily have to do it this way, but I find that this way gives me bigger and better dynamic of how the cylinder is actually looking, and then clearances, piston to wall clearances throughout the whole cylinder. And just like the main bearing diameter, I'm going to loosen the tool, slide it in. You want it to be straight across, straight up and down, and go ahead and tighten it. Make sure you can move it about the bore and it just catch just a little bit. And from that measurement, throw this in our micrometer. See what we've come up with. So with that measurement, I got 80.96 millimeters. Now it usually is a little tighter across this section, as the thrust surfaces need a little bit more play in them, I guess, or tolerance. But across here usually it is a little bit tighter because it doesn't have, the skirt really doesn't come down on the side. Let me grab the piston real quick. So as you can see, thrust surfaces front and back, on the sides there's not really skirt there, so it can have a little tighter of a tolerance here, but these have more metal, which means they will expand more, so they need a little bit more tolerance front to back on the thrust surfaces. Let's go ahead and take our front to back measurement and see what we get. You could already hear, I just loosened the tool and you heard the clink. So there is a little bit more space front to back. Let's see what we come up with. With that measurement, I got 80.99 millimeters, which everyone will probably agree that's 81 millimeter right there. I'm gonna go ahead and get the rest of these banged out, and then we'll pick up after that. So all of the cylinders are measured, and they look pretty good. I mean, I would say the average is probably 80.99 millimeters. There are a few that are a little tight, like right here. That could have been my mistake. I need to check that one again, but 80.92 mil. But the rest of these look pretty close to 81 overall, and this is a good base for our piston to wall clearance. As soon as I get the pistons back from the machine shop, I'll be able to mic those and finish miking the rod bearing clearances, and then from there we should be able to start pinning the tail on a donkey and putting this bitch together. So go ahead and like, comment, subscribe. Until next time, get this bitch on the road, hopefully before my birthday, project birthday build. And yeah, I'll catch y'all on the next one.